Hello and welcome to my YouTube channel. I'm German, so please feel free to correct any of my English mistakes I'm doing in this video. Besides grammar and spelling, everything you know, please change it and write down in the comments what to improve. I say welcome to everyone who's new on the channel, and especially hey Thomas, you've been the one who inspired me to do this video. I will do this video without any editing, maybe a little short cut if the battery dies or I get hungry. I really want to say thank you for the conversation we had below your video, and now I think it's time to talk about a few things I'm working on. I really like your idea of tilting the keel and tilting the weight to the side of the hull. I will take another approach and tilt the mast and the rudder, the mast leeward, but I also think about tilting it leeward, kind of like these beach sail racers. I don't know the correct word for that yet. To ensure that, my first idea was to build kind of like this, where the center point contains the mast with a rod, and inside this cabinet the mast can rotate, and I use a servo winch to pull the mast from side to side. My first idea was to mount a roller, a block on here, and then pull with strings up there. I quickly changed my idea, and the new plan is shown in the video later on. The idea of building a foiling monohull isn't new, and my approach is a little different. I want to use a boat with a rudder T-foil, and my first idea was to build this T-foil just as you would expect on this boat, rather big and vertical. I made some prototypes like this one. It's not the prettiest and it's not tested, to be honest. It's not done yet. This one is tested on a basic boat. It works. It's not producing any lift, but it's definitely correcting the boat in waves. It's rather neutral, and the surface area is, I think, quite good in size. It could be maybe a little bit bigger. The next T-foil I got is extremely downwards. I'm sure you can see that. I haven't tested it yet, but it's ready to test it. The surface area increased by quite a bit, I think by a third. So let's see what happens. One thing to consider in this project is that if the boat heels, let's draw a water line. Now the water is flat. You would produce the lift up there, and that's not vertical. So to encounter that, my idea is to bring the rudder below the boat. So the T-foil is producing real lift. So it's perpendicular to the water. This is a basic hull of a model boat, and what I came up with is this rather strange slot. It's ending in this simple single hole, and if I can show you correctly that the rudder is able to turn and also tilt. You might get seasick because I'm not holding the camera still, but I think you can get what I mean. Now the rudder is tilted like 40 or 30 degrees, and if the hull heels to one side, we're now producing real lift, vertical lift out of the water. To produce the maximum speed for the boat, you have to keep the mast as vertical as possible. That's why I came up with this idea. It's basically a tilting mechanism for the whole mast system. In this case, the shrouds are not attached. They would get here, go up to the mast top. The vang is fixed, and you can adjust the length of the boom to adjust the tension for the vang. The mast is just stick on this tube. I have to come up with a solution for that. If you get a solution, please feel free to comment down below and subscribe so you can see if I did what you said. The whole system is balanced on these ball joints from an RC car, which are what's the correct word? Which make it possible to adjust the rake of the mast and also the tilting angle by putting some washers under here. The tilt would be different in a different angle, so I can adjust the rake for the mast basically like this. If I would push a washer under the forward ball joint, the mast would tilt further back. The mast is rather short. I think it's now 1.2 meter, and I have a way too long boom, but that's just prototyping. We will see how long the end result would be. Now we have to talk about some foiling situation solutions. This is a normal foil I built for a hydrofoil for kitesurfing. Never used it because I can't foil surf, but my brother does. So I can't tell you if this one would work for my boat, but I sure will find out. I think about cutting it up and putting it vertical next to the boat. There are several solutions already made by other people. The first is a normal DSS system. It describes a normal hull, which got a righting moment by a normal foil, which is usually not that long, and the water line goes around here, and the foil creates simple lift. The next system I like really is made by Thilo Keller. It's from the foiling dinghy. You can Google it, the foiling dinghy. It's basically the hull. Let's find out if I can draw that. With a foil system which goes under the boat, creating lift, and not having any surface area to reduce the drift. And for reducing the drift, we use the second foil, which is tilted like this. There are bearing points in these two sections, which allow the foils to switch. Now the leeward foil is producing lift against the drift, and the leeward foil is producing lift upwards. I think another clever idea is the one Beneteau came up with for their Figaro 3. If this is the hull with a normal rudder and so on, they put the foils on top of the boat and into the water. That's the water line. that produces a good amount of lift in this way and not a lot of drag, because the whole area in between is not in the water, and we get a long distance between lift and center of gravity, which makes the writing force much greater than if it would be just below the hull. Like Wild Oats showed last year, I think another solution would be just a normal flat foil. We have waterline. The flat foil is just coming out of the side of the boat. The downside of this solution is if you have a boat which is tilted and the foil gets out vertical, the more it tilts, the less foil lift would be produced. It's always producing the lift in the wrong direction. Only if the boat is sailed perfectly perpendicular to the horizon, then the foil produces the perfect amount of lift. If that's the horizon and you have a boat here and the foil comes out of the boat just below the water surface, then you get lift. Let's finish the boat. There's someone sailing on. Yeah. I think the most sexy way is shown by Hugo Boss, and that's basically this solution, but way longer. What this ensures is the boat's heeling. Let's use this drawing again. If the boat is heeling, the foil produces a well amount of lift, and that's really good. The last solution I want to talk about is the one shown by Gonet monofoil. We can draw again the hull and the mast, and they created a foil system which is triangular, like this. What this ensures, if the boat is in normal condition, we have a same amount of lift of these two areas, and the more the boat heels, the more lift we get up here, and the less force is pushing the boat towards the wind, because the drift would increase, because this area is also decreasing. But the righting moment is increasing by more angle for the keel. Let's draw it slightly heeled. This is our boat. This is the mast. This is the keel. And this is the triangular. Now the surface produces the lift, very flat and very strong. We have a lot of force pulling the boat in the correct manner, and we increase slightly the drift, which decreases the power from the sail. I think that makes sense, so we can keep pushing on that. It would be really helpful if you go through the video again and look for any mistakes I made to improve my English and the upcoming videos. Thank you for watching and subscribe.